Hello and welcome to By Excellence Tutorials. And in this video, we are going to solve this question, which is partly, we can look at it from momentum collision point of view, can also look at it from work done point of view. All right, so it says car one was sitting at rest when it was hit from the rear by car two of identical mass. So identical mass, basically it means they have the same mass. So if car one was 50 kilogram, also car two is 50 kilogram, all right? And both cars and their brakes on, and they skidded together 6 meters in the original direction of motion. If the stopping force is 0.7 by, which is combined weight of the cars, where the coefficient of friction is 0.7, find the approximate speed of the car two just before the collision took place. All right, so we have something like this, where we have the car two is moving in that direction, and we have car one at rest. And then what happens is that at this point of collision, they move a distance together, just sticking together. They move a distance of 6 meters, all right? And we have something to do with the friction force here. So we have something to do with the friction force. And now we are being asked to say, what was the speed at which car two was moving at before the collision took place? So how do we solve that? All right, let's look first at the stopping force of the friction force. So we are told to say the friction force is 0.7 by the combined weight. Combined weight. So let's say car one has got the mass M, meaning that car two also will have the mass M because they are identical. So the total mass is going to be 2M here. So now weight of this is, we know that weight is mass times gravity, so it's going to be 2M times G. So that will be the mass. Now, this one, we know that it's going to be that, and this is friction force, mind you. So it's opposing, so we have to put a negative sign, seeing that even the acceleration is going to be retardation, as it will be going to rest, as the final here is 0. It's going to stop, the stopping force. So we have negative 0.7 times 2 mg, the combined weight. So that is going to give us what? It's going to give us 1.4 or negative 1.4 mg. All right, so now we know that there is motion here. Motion, it has not stopped. After the collision, they moved a distance of 6 meters. So now we want to know the deacceleration or the retardation after the collision, before it came to rest. What was the acceleration? All right, this is what we're trying to look at. So we know that the friction force is also given as mass times the deacceleration. Friction force, mass times the deacceleration. So that what we have is the mass here is the total mass of the two cars, car 1 and car 2. So we have friction force being equal to 2m times a, or the acceleration. So this equation and this equation are the same. So what we have is what? Is 2m a being equal to negative 1.4 mg. All right. So that and that and over 2, we're going to have negative 0.7 g as our acceleration or deacceleration. Okay, so we were just trying to use what we have just been given in the equation to say, take the stopping force to be this. So this is what we were doing here. Now, let's look at what will be the, what's this? The velocity. The velocity just after collision. We know that the final is 0. So let's say we're going to have, we have this formula. All right, so we have that formula. So now, let's say u2 is the velocity immediately after collision. This is the velocity, u2. So what we're going to have is, it's going to rest. So we have 0 and we have u2, which we want to find, plus 2. Acceleration is negative 0.7 g times 6 meters here. So what we're going to have is negative u2 squared being equal to negative. So if I punch everything, I'm going to have 82.404. So negative and negative goes, and then we square root both sides. We're going to have u2 being equal to 9.08. So I have u2 being equal to 9.08 meter per second. So this is the velocity the cars moved with, the combined cars moved with immediately after collision. So why is this important? Because this is going to help us now to know the velocity at which the before collision the second car had. So now, what do we use? We use momentum, conservation of linear momentum, because in any collision, momentum is conserved. So what we're going to have, conservation of linear momentum, we're going to have, let's say, mass 1 all right, so this is just the equation. Times the uniform velocity. So now, what is happening here is that mass 1 is at rest before collision. So what we're going to have is 0 here. Or let me rewrite and say we have that plus we said that mass 2 is the one that is moving. 2m u2. They moved with u2, this one which we've just found here. So now, This one was at rest, so no momentum, and we're going to have m u1 equal to m 2m u2. So don't get confused about the subscript. I'm just yeah. So m and m goes u1 to u2. So this u1 is just the velocity at which the mass 2, the one that was moving, had before the collision. So we can say that this is given by 2 times 9.08 meter per second, and this is going to be multiplied by 2. We have 18.2 meter per second. Okay, so that is the velocity or the speed at which the moving car was moving with before collision. So that is how you find that one. I hope you understood. Yeah, because our goal, or my goal, is to see you happy. And happiness to me is understanding and clearing physics. Stay glued to the YouTube channel. Give me the reactions, share the video, and I'll be encouraged to upload more. And give me a comment by giving us the feedback. Thank you so much.